see the screen, and it's the booklet. So a very quick reminder, hopefully everybody knows where to get the booklet, is if you go to the level 2 course and you go to content, then you will see the 2.1 standard over here, and look at the first one, the introduction. And then with the introduction, you'll get something like this, and that will give you the booklet. You can choose between DocX or PDF, and then the answer guide. So that's just where we got it. You don't work through the modules. As you can see, the title of the standard is different. The standard has changed, so work through the booklets. You only go to the modules to get the booklet or to get the teacher marked assignments. Okay, let's get started. So what we've done at the moment is, or in previous lessons, we looked at how we count atoms because they are just so tiny. So we had to first work out, do we know the elements, and can we work out the number of atoms or ions of that element in a particular substance? And then we worked out how we could work out the mass of a, and we introduced this term mole, which is like a how we count. So we could say a dozen eggs means 12. When we talk about a mole of atoms, it's 6.02 times 10 to the 23 atoms, which you don't really need to know that number. You just work with the masses given on the periodic table. The error I will get back to next term when we focus very much on the 91911 standard. But we did look at significant figures. If you're aiming for excellence in any of the exams or in the titration standards, you do need to watch your significant figures. That's your measurements. So that is important if you're aiming for that, but I would say go for it at all the time. Then we introduced the formula of n is equal to small m over big M, and we saw how we would use that formula. And of course, I stress again, this formula is only useful if A, you know what those quantities stand for. So let's do a quick quiz. What does N stand for? What quantity? Mass, molar mass, or number or amount? Number, amount, same thing. Would anybody like to type into the chat? Is it mass, molar mass, or amount? The N. Anybody want to have a go? Nobody? If you want to know where the chat is, it's in that little bubble. It should be at the top of your screen. Amount. Thank you, Campbell. So amount is the number of atoms. The M, what do you think M would be? Anybody want to have a go? The mass, great. And the capital M? The molar mass, great. So you do need to learn those. Great, molar mass, correct. So because you're not going to get your calculations right if you put the values, the numbers in the wrong place. So you must make sure you make flashcards, or there is a little game, you can play in the Quizlets to try and memorize what those mean. And related to that is, of course, the units, because when we give you a value, like we say 10 grams, then you need to know, gram. I think somebody's got their mic on if you wanted to switch it off, unless you want to say something. So if you see 10 grams, you go grams, that is the unit of. So quick quiz, what do we measure? What quantity do we measure in grams? Mass, molar mass, or amount? The mass, correct. And if we have the unit of mole, what do we know we have to calculate? So mole is the unit of what quantity? No, neither of those. So mole is the unit of, it's got to be either amount or mass or molar mass. So I don't think I saw any of those answers. I could be wrong. They sort of pop up on the screen. So it's if the unit is mole, then it is the quantity is amount or number. Okay, so it's N that we're looking at. And if the unit is grams per mole, what quantity are we looking at? Mass, molar mass, or amount? If we see the unit gram per mole. Okay, no, right, molar mass, correct. Now, if you weren't sure of this, then just make sure when you work through the booklet, you do spend some time to learn those before you move on. With practice, you will learn them quite quickly, but you'll find things a lot easier if you learn those. Okay, so let's carry on now. Then we looked at, oh, sorry, went too quick. Sorry, I'm just going to take it up again. Then we looked at using that just for one substance, but if we want to use it for two substances, so say I've got chlorine gas, and I want to know how much chlorine gas do I need to form 10 grams of table salt, sodium chloride. So I am swapping from one species, which is chlorine gas, to sodium chloride, or the other way around, but I've got to go from one to the other. I cannot use what I call apples with apples with oranges. For example, if I said I have a basket of oranges and the basket weighs 10 kilograms and each apple weighs 100 grams, how many oranges do I have? Could you answer that? I said my basket of oranges weighs 10 kilograms. Each apple weighs 100 grams. How many oranges do I have? Could you work that out? Yes? No? No, you couldn't. Okay. It's the same thing with this. I cannot, you have, say, for instance, my amount, if I'm trying to work out chlorine gas, if, say, for instance, my molar mass was sodium chloride or sodium or chlorine atoms, it's got to be the amount of chlorine gas with the mass of chlorine gas and the molar mass of chlorine gas. I can't have bits and pieces from elsewhere. So how do we swap from one species to the other, from say chlorine gas to sodium chloride? If the formula only applies to one, I have to use the mole ratio. And that's we get from the equation. Now, we will, when we do the titrations next week, go revisit that concept. And that's where we introduced here the mass to mass calculations, swapping from one substance to the other. Then we looked at another formula of calculating concentration. So I'm going to pop there straight away. And this is where we looked at concentration. It's the amount, so the number. So you can see that is the N. And it's divided now by the volume. How many particles, so what amount have I got in a certain volume? So we have the formula of C, which is my concentration, is equal to N, which is my amount, divided by my volume. And again, you've got to know your formulae, so or your units. And so I'm just going to scroll it down. There are links to the videos, where things are being repeated. Let me go down a bit further. So again, we have amount is measured in mole, so that is N. Volume is measured in liters, therefore concentration is measured in moles per liter. So again, you need to know those. There's a big trick here, because when we are in the laboratory, we don't slosh liters of stuff around. We tend to work with little things. So you tend to measure things in milliliters, but of course, I can't say, milliliters and then expect to get a unit of moles per liter. So I always have to convert milliliters to liters, and the easiest way to do that is just times it by 10 to the negative 3. So if you've got your calculator, depending on what sort of calculator you've got, whoops, sorry, mine's very old-fashioned one, you might just hit the exponential button, but I think most of you have programmable calculators, so you should be able to work it that way. Any questions so far? Because I've done a lot of talking. I am summarizing what I've done before. No questions? Right. So what we're looking at now, I want to now look at where we convert or use the two together. So if I have, so we've done the concentration and we've done the conversion. So I'm just going to go down here where we look at mass percentage calculations and calculating concentrations using mass. So here's an example, and this will be given, say, in the assessment task. You will be given a bottle of something and you're told it contains a certain compound. Could be ammonia, it could be vinegar, ethanoic acid, or in this case, sodium hypochlorite. And in the shop, the way things are sold, it's given as a percent. And what that percent means, it means 5.0 grams in 100 milliliters. Why 100? Well, because percent, cent means century, 100. So that's where the 100 comes in. Anything that you get in the shop would be always the mass in 100 mils. The only time when it's not that is if you've got a liquid dissolved in something. So for instance, alcohol, if you look at a wine bottle or a beer bottle or so on, if it says, say, swap that. If it said, say, for instance, 8% alcohol in there, then it's actually volume. So it's 8 milliliters of alcohol in 100 milliliters of the solution, the beer or the wine or whatever it is. Okay, so we're going to be looking at mass percent. So for instance, sodium hypochlorite is not a liquid, it's a solid. And so we weighed out 5 grams of sodium hypochlorite and dissolved it in 100 milliliters of water. So you've now got to convert this unit of 5% to moles per liter. Sorry, that pause was just to get somebody in. Okay, so what we're going to be doing is these particular steps. So pretty much you've got to say, if I've got 5 grams in 100 mils, we don't work in milliliters, so let's rather do it in a liter. And of course, to go from 100 milliliters to a liter, I'd multiply by 10, because it needs 10 100 mil sections to become a liter. So 5 grams in 100 mil will be 50 grams in 1,000 mils. Then I just simply have to work out the molar mass, so I can work out my amount, because remember, I need, if this is grams, and you know your units, you know that this is M. But we want to have a unit of mole per liter. So we want N. And how do I change M to N? I use the formula N is equal to small m over big M. And that is why I need to calculate the molar mass. Now, again, in assessment tasks and exams, they always give you the molar mass. It's very, very, very rare for you to have to calculate it. The way you calculate it is you're always given a periodic table with the units. Okay, so once I've got the molar mass, I simply take the mass I've worked out, divide by the molar mass I've calculated, and that gives me the amount in mole, the N, and of course that is already in 1,000 mils, so it is that many moles per liter. So it's straightforward. So let's do some examples. Now, in this case, it's always the same substance, but it's always a good habit to always write the same substance in here. So you know you are always dealing with the same thing. So what is my mass of HCl? It'll be 36.5 grams in 100 mil because that's I get directly from the percentage. So how much would it be in 1 liter? If it's 36.5 in 100 mil, then in 1,000 mil or 1 liter, it'll be how much? Does anybody want to have a go? 365, correct. 365 grams. Now I have to calculate the molar mass of HCl, and I'd look it up in the periodic table, and it's 1.0 for hydrogen plus 35.5 for chlorine, so it's going to be 36.5. You can see I've chosen very easy examples. So that's going to be grams per mole. So in order to work out N is equal to mass over molar mass, which is 365 grams over 36.5 grams per mole, which gives you an answer of 10 mole. Now, you should keep your significant figures correct. That's got 3 significant figures, got 3 significant figures. So you should put 3 significant figures here. And that unit there is mole. So whenever you've done a calculation, go, do I have units? Do I have the correct number of significant figures? And is that answer sensible? And yep, that's quite a heavy for HCl, so I would expect it to be 10. So now to calculate it, I've now got for HCl in 1 liter, I've got 10.0 mole. So it's in 1 liter, 10 mole per liter. So my concentration of HCl is going to be 10.0 mole per liter. And again, in your final answer, check that you've got units, check that you've got the correct number of significant figures, and then also just think, is my answer sensible? Any questions so far? Pretty straightforward. I think the hardest part here for people is to work out the molar mass. And as I say, in the assessment, you're given the molar mass. Is there anything that you're not sure about? Okay, well, it'll come with practice. Let's now carry on with the other type because I want to finish the other type. And that is doing the reverse. So you are given the concentration in moles per liter, because this is how you finish the assessment task. You've worked it out in moles per liter, and then you have to then work out the percentage concentration and compare it with the given value and say, yep, my vinegar, has the right concentration as stated on the bottle. Or you might say, no, it doesn't. And then you need to explain why. So if you think of how to do it in reverse, you are given, let me go up a little bit. You are given a concentration in mole per liter. And if you've got this, then this is, remember, 0.545 mole. So it's N, we're looking at N over V. If we want percentage, we need to get to mass. So how do I convert N to small m? I have to use the formula of N is equal to small m over big M. But in this case, I want to have M. So remember, if you're not sure how to change the subject of the formula, to go M is equal to N times big M. If you're not sure about that, you can use that triangle where N, small m, big M. But again, you've got to remember the triangle correctly. So if I'm trying to calculate mass, then you can see I have to do the N times the big M. Okay, so you can see it's pretty straightforward. My amount is going to be 0.45 moles per liter, which means in 1 liter, I'm going to have 0.45 moles. And so in order to calculate mass, remember it's N times M. So it's the amount in mole times the molar mass we've calculated up there. And then that is our mass in 1 liter. But remember, we want percentage, which is not in 1 liter. We want it in 100 milliliters. So what do I have to do with my value of 26.3 to get it to a percent? Because it's not in 1,000. Well, I just divide by 10 actually, because I'm going from 1,000 to 100. So I know you think of percent, so you think, okay, that is percent, it means divide by 100 or something like that. But here it's just really, I'm going from 1,000 milliliters to 100 milliliters. So that difference from 1,000 to 100 is just a 10 times difference. So I simply have to take my 26.3 divided by 10. So it means I've got 2.63 grams per mole. Sorry, not grams per mole, 2.63%. And because we were only given 2 significant figures the first time round, you can see I've rounded it off to 2.6%. So let's do an example sort of from scratch. So here's sodium carbonate, and you're given a concentration. So again, this is just to try and get you into the habit of thinking about what substance you're talking about, because you will be given more complicated ones where you've got to swap from one substance into the other for other examples. So my molar mass is I've got to calculate it. So I've got 2 sodiums, so it's 2 times 23.0. If you're wondering where I get this from, I know it's off by heart, but it's from the periodic table. I've got 1 carbon atom, so it's 12.0, plus I've got 3 oxygen atoms. Each oxygen is 16.0. So my molar mass is going to be and hopefully one of you lot have beaten me and have already worked out it's 106. Now remember, always units, grams per mole. My concentration of my sodium carbonate. So here I'm just sort of taking from all the given information. So it's a list of everything I know, and you can always work out molar mass. So this is 0.250 mole per liter minus 1. So to work out the concentration, it just simply means in 1 liter, I've got 0.250 mole. Okay, so my mass of sodium carbonate in 1 liter is going to be my amount times by molar mass. And I get that from this formula, remember? And so that's going to be 0.250 times the molar mass, 106. And that gives me then the answer of times 26.5. Okay, grams. So remember, always look at units. I am working out the mass. So my unit is gram. And you look at significant figures. I had 3 significant figures there. So my answer's in 3 significant figures. But this was in 1 liter. So to do percent, which is 100 milliliters, what do I need to do? I need to divide, and I need to divide by how much? Divide by 10. So my answer is going to be 2.65%. And again, because that was given to that was given to three significant figures, I'm going to give my answer to three significant figures. Okay, so do you think you can do this sort of thing? So this is where we've now using the C is equal to N over V, and also bringing the first formula we learned about N is equal to small m over big M. Does this seem difficult? Do you think with practice, once you've worked through the booklet, you'd get to know this? Deathly silence, or is it all very easy? Yeah, with practice. And remember, it is practice. Yep, you've just got to get the hang of it. You can't expect it all to just go into the head and do it. And that's why we are recording this. You can watch it again, but just working through the booklet should be okay. So, lots of it. If you want more practice examples, just ask your teacher and we'll give you more. Okay. So just where we're at now, so I'm just going to go right to the top. So you could, because last week we did dilution calculations. So when you've done up to this point, you can complete the second teacher marked assignment, 2012A. And remember, this is the only time you go into the modules, is where you go to the last lesson where it says teacher marked assignment, and you download that and complete it. So next week, we are going to do just titrations. So we're just going to be doing this. We'll be revisiting mole ratio. So we're just going to look at that one. And then next term, because there are normally chemistry days towards the end of term 2, normally in Hamilton and Auckland. It's all COVID dependence and so on. But it's normally then Christchurch, Hamilton, Auckland, and Hastings is normally something at the end of term 2. So if you can go there, Wellington, you can do it any other time. And I know some teachers can sort of go get you an advisory. So we may even be trying Dunedin as well, if any of you in Dunedin. So that's normally the end of term 2. So at the beginning of term 2, I'm going to be focusing then only on the 91910 standard. And that's when you need to know all about errors and so on and so forth. So that'll be 3 lessons next term, and then we've covered this whole standard. Any questions? Okay, I'm going to stop recording.